imagine looking out, way out, across these just vast cosmic distances, far beyond our own Milky Way, and you get to see the universe actually building its grandest structures. It's pretty humbling, right? Well, today you're getting an incredible look at exactly that kind of cosmic construction project. Our deep dive today is all about this brand new, super detailed image of a galaxy cluster called Able 3667. And look, this isn't just a pretty picture. It's a window into the violent ancient past of these huge structures. And honestly, it's also a sneak peek into the future of how we even image the universe.
Yeah, absolutely. So our mission today really is to unpack what galaxy clusters actually are. And, why this new picture of Able 3667 is such a big deal, and how it gives us what some astronomers are calling whispering evidence of cosmic history, all thanks to some truly revolutionary tech.
Okay, so let's dig in. When we talk about these immense structures, what exactly is a galaxy cluster?
Right. Well, galaxy clusters are really among the largest things in the universe. We're talking hundreds, maybe thousands of galaxies, all held together by gravity, evolving over billions of years. What's really fascinating, I think, is that watching them form helps us understand not just, how the universe began, but also the weird properties of dark matter. That stuff plays a huge role in holding them together.
Okay, dark matter too. And this specific image of Able 3667, it's like 700 million light years away, right? And people are calling it the deepest one ever taken. I mean, what kind of astronomical power does that take to capture something that big, that far?
Oh, it's a real masterpiece of modern astronomy. It really is. It was carefully put together from more than 28 hours of observations using the 570 megapixel dark energy camera, DCAM for short. It's on the Victor M. Blanco 4-meter telescope.
Yeah.
And that incredibly long exposure time, that was just absolutely essential to capture the really, really faint details.
Right, the faint details. And that leads us to this idea you mentioned, whispering evidence. Tell us about this intracluster light. It sounds almost, poetic.
It kind of is, actually. Intracluster light, or ICL. It's this very faint glow. It comes from stars that have been basically stripped or pulled out of their original galaxies, pulled out by the immense gravity as these clusters form and merge over time.
Ah.
So it's like cosmic breadcrumbs. It's direct evidence, like a fossil record, of all the interactions that happen inside the cluster. Most telescopes they struggle to see it. It's too faint. But it really shines in this Able 3667 image.
Wow. So we're literally seeing stars ripped from their homes millions of years ago. And inside Able 3667 itself, there's even more going on, something about a glowing bridge.
Yes, exactly. This image clearly shows two smaller galaxy clusters right in the middle of merging, actively merging. And you can see this dramatic glowing yellow bridge of stars stretching right between them.
Oh, yeah, I see that.
That bridge connects the cores, the hearts,
Yeah.
of the two subclusters. It's made of material ripped away during this colossal collision. And you can also spot these faint sort of bluish strands. That's different. That's interstellar dust in our own Milky Way. Astronomers call it cirrus. It's just foreground stuff lit up by nearby stars. It's kind of like wispy clouds.
Okay, so merging clusters, stripped stars, even foreground dust. This DCAM image feels like more than just one picture. It sounds like a big hint at what's coming next, right? What does this deep view mean for the future of exploring the universe?
Yeah, you've got it. This view of Able 3667 is basically a preview, a sneak peek, because the NSF DOE Vera C. Rubin Observatory is getting ready to start its big survey, the Legacy Survey of Space and Time, or LSST, later this year, actually. And it's set to just completely revolutionize how we study this faint stuff, like intracluster light and a whole lot more.
How's that? What makes Rubin such a game changer?
Well, Rubin uses what is literally the largest digital camera ever built for astronomy. And its job is to image the entire southern sky every few nights for 10 years straight.
Wow, the whole sky.
The whole southern sky, yeah. Its data archive will just contain millions of these super high-resolution images of distant galaxy clusters. So scientists will be able to stack these images, combine them to create these ultra-long exposure views. They'll get the same kind of depth we see in this one Able 3667 image, but potentially for the entire southern sky. So, it really makes you wonder, what other incredible features, what other faint cosmic whispers are we going to find when we can see like that across such a huge area?
That's incredible. So just like that, we've taken a deep dive into Able 3667. We've looked at how galaxy clusters form, what this intracluster light tells us about their rough past, and how amazing tech like DCAM and soon the Rubin Observatory are really changing our whole view of the cosmos.
It really does make you think, doesn't it? So imagine, what other secrets are still hiding out there? in that faint, distant light from across the universe. Just waiting for us to build the tools like Rubin to finally hear their whispers. What deeper truth about how everything evolves might that finally reveal?